Introducing 3D Focus Fusion. When using optical microscopes, we are often annoyed by the limited depth of focus, which makes only part of the image sharp. This is particularly noticeable when samples are uneven and a high magnification objective lens is used. Bruker's 3D Focus Fusion technique produces microscopic images with great depth of field and clarity by merging multiple images with various focus settings. But it's not only visual quality that benefits from focus fusion. Raman imaging is enhanced too, as now we have topographical information. This way, the fully automatic XYZ stage can perform the Raman measurement always in focus, guaranteeing the best signal-to-noise ratio. Let's take this diamond tool as an example. Clearly, the surface is tilted and uneven. Of course, 3D Focus Fusion will generate a crisp and clear image. Now we perform a Raman mapping across the tilted surface. The spectra's Raman signal at 1332 wave numbers corresponds to the vibration of the sp3 diamond lattice and indicates the presence of pure diamond. A sharp Raman peak usually represents a structurally perfect Type 2A diamond. But let's take a closer look at the data. This image shows the full peak width at half maximum of the diamond at the respective positions. The particle in the middle clearly shows broadened peaks, which indicates defects in the diamond. But let's double check by investigating the peak shift relative to pure diamond at 1332 wave numbers. Here, we observe the same situation. The middle particle shows a strong peak shift, confirming the presence of defects. Even for this tilted surface, we received high-quality Raman imaging data, thanks to 3D Focus Fusion. With this, Raman spectroscopy and optical microscopy are joined together better than ever. Thanks for watching.